Welcome to Eagle Complete course. In this course, we will be learning about simulation in Autodesk Eagle. The simulation feature in Autodesk Eagle is Spice Simulation. It is a great tool to verify circuits design. Whether it is a simple check to make sure all the diodes are receiving the current they require based on chosen values, or checking that the gain and frequency response of a carefully designed analog match hand calculations. Simulations can be a powerful input to validation of a design. Eagle currently supports operating point, transient time, AC frequency, and DC analysis types, full digital and mixed signal simulation modes. You can simulate any valid SPICE circuit using Eagle. This means all components in your schematic have been mapped to SPICE model, either primitive or model-based. For this simulation example, I will make a new schematic project and make a simple circuit. Here, I will make a new schematic file for our simulation circuit. First, go to the grid setup and turn the grid on. After that, you can start to add the component to make your circuit. We can choose our component from the ngSpice library that Eagle provides here. To make sure your schematic is ready for simulation, we need to do this following process. First, select all the parts in your schematic, then run Add Model command. It can be started by right-clicking on a part and choosing it from the context menu, or by command line or toolbar icon. If you have ground or GND symbol in your design, it will ask if you want to convert them to Spice ground. Choose yes if that works for your design. You can also do this on a part-by-part basis, and you can add or create a ground later. Every simultable schematic needs at least one Spice ground connected somewhere in the circuit. Next, you will be presented with a table showing all the parts in the design. It also shows whether they are simulation ready. The Done column should have a green check mark for all parts, what type the simulator will assume they are when performing calculations, and their value and units if applicable. The last piece of information is the Spice model. Not all parts need them. It is based on the selection made in the Spice type column. The Spice type chosen in the drop-down for a given part will tell Eagle whether it needs a Spice model or not, and if the part symbol needs to be mapped to Spice model inputs. Click the Map button on each part that requires a mapping. For a simple built-in passive device like resistor in my schematic, the mapping dialog will look like this. There is no file to load, so it will go right to the map pin step, where you need to tell Eagle which pins on the symbol go to which pins on the Spice model. In this case, the Spice model for a resistor is already known to Eagle to have two inputs called N1 and N2. So, the mapping from the symbol to the model is simply to tell Eagle which symbol pins match to which model inputs. Once you have mapped the symbol to the model, the table will refresh and all instances of that device type will show as done and ready for the simulation. You do this for each part in the schematic that is marked as not done or no green check mark. There are also some parts need model files to be loaded. I will take this 7805 for example. For parts that require model files to be loaded, after you click Map in the table, it will go to the Load Model tab shown, where you will load a model file, decide where it should be saved, and then continue to the symbol mapping. Once all the parts are mapped, you are ready to go. So that you have parts readily available to you that are already mapped and ready for simulation, it is suggested to define the spice type and map models from within the library editor. The same operation applies. Just start the Add Model command, and you will be brought to the same table-based mapping dialog as when doing it in the schematic. The only difference being there will only be one part in the list. If you have multiple gates in your device set, you will see multiple entries. Just choose the spice type, load models if necessary, and map the symbol pins to model inputs or outputs just as you would in the schematic. Once done, Eagle will save the mapping and models if applicable in the library. So, wherever you use the parts, they are simulation ready. Once the schematic is ready for simulation, run the simulation command. Note that you can try this by opening any of the pre-made examples in the Examples ngSpice folder shaped with Eagle. When you start the simulation command, you will be presented with the simulation dialog as shown. The first tab activated is the configuration. Here, you decide what type of simulation you want to run and what parameters you need to supply. The left-hand side contains all of the available simulation options. Operating point is selected by default since that's what our design is configured for. There are currently 4 supported types of spice simulation: the AC, DC, transient, and operating point. If you choose an operating point type simulation, you need not change anything else, and you can just click the simulation button. An operating point analysis is useful when you want to view information such as voltages or current levels at startup. If you choose DC sweep, this means you want to vary one voltage or current and see the DC response of the circuit. For example, to see how it reacts when the power supply goes from 0 to 3 volts. From the source drop-down, Choose an independent voltage or current source and give the start and end values for the sweep. Then, if you choose AC sweep, it means you want to simulate your circuit over a range of frequencies. For example, to see if any amplifier will work well with a low and high frequency input. Choose the AC sweep type, DEC for decade, or long scale, and LIN for linear scale, and set the start and end frequencies. Then, if you choose a transient analysis, then you will simulate your circuit over time. Set the start and stop times. For example, you might want to simulate a 1-second timer circuit over time, from 0 to 5 seconds, to view the timer operation works as designed. Tmax is an advanced setting used to set the maximum time step that the simulator should use. You can leave it blank. The default value should be good for most situations. On the right, you have your DC sim and transient sim options. You likely won't ever need to change these values unless your simulation runs into converging or timestamp issues. The next step here is the Netlist tab. Netlist tab displays a raw text format of our netlist configuration, which includes our simulation settings, devices, models, and more. The netlist is a text-based representation of our visual schematic. If you change values here, it won't change anything on your schematic. Under the Options heading are all of the values that you set in the Configuration tab. You can also change these values directly here if you'd prefer. Look under the Device heading, and you'll see all of the parts connected in your schematic. After that, here we can see the Output and Plot tabs. These last two tabs are where all of our simulation outputs will display. Raw text results will display in the Simulator Output tab, and the Plot tab will provide visual graph for transient analysis methods. Since our operating point analysis is only measuring values at a single point in time, results will only be displayed in the Simulator Output tab. Autodesk Eagle also provides us with several simulation examples. I will show you the digital circuits to demonstrate the plot output. Since this is a non-editable circuit, we only can run the simulation. The output of the simulation of this circuit is a plot showing the signal output of this digital circuit. So, that is how we can simulate our circuit using SPICE simulation on Autodesk Eagle.